We're shaking wrestling.
Oh, right, when they call you out and then you go shake
But
their hand.
they always shake it like they're like just my fingertips.
Limp.
I'm like, what are you
That's
doing?
no good. Gives me the heebie-jeebies.
Yeah.
All right, here we go. Number 1, 19.3. Number 3, 14.5. Number 5. Did you do this, Ryan? You were at the bathroom when I checked it. Right. Number 5, 24.8. Questions on 1, 3, or 5.
What is this?
Jake did that during lab.
All right. Shh. No questions on those. All right, flip it. All right. Here we go. So I showed you the hydrated salt last, was it Friday, I think? Yes, I came around with the blue crystals there. Hey, stop talking. Jake, sit more like professional.
Yes.
There you go. Thanks.
Wrong.
All right. Now, if I took those blue crystals and I heated them up, I think Devin answered this. What would happen? Last Friday when I showed you those were the hydrate.
All the water in that.
Yeah, the water would evaporate. So when I'm reading this question, it says a hydrated salt is a solid that includes water within its crystal structure. We talked about that. Student heated 9.1, so we have 9.10 grams of the hydrate. Okay, so the student heated that up to a constant mass of 5.41. 5.41 grams. Now, what does constant mass mean? Bree, what does constant mass mean here? Forget the question for a second, just the words constant mass. Not changing, very good. So what would happen is if we took those blue crystals from Friday and we massed them, and then we heated it up, let it cool, and then massed it again, the mass would drop because the water evaporates. I hope you guys follow me with that. However, not all the water would be out of it on the first shot. So you'd have to heat it up again, let it cool down, and mass it again. If you get the same mass twice, that's called a constant mass. So whenever you're trying to get a hydrate, the water out of the hydrate, and I usually do a lab with this, but because of my whole leave and everything, we're not going to do it. But usually it takes 2 or 3 times you heat this up, then the mass will stay constant because then all the water's out. That's what that means. This is called an anhydrous compound. Steph, what's anhydrous mean? Right, an means no or anti. Hydrous means water, no water. So this has no water, this has water in it. Edwin, if we subtract those, I get 3.69. What does that tell me?
That's how much water was in it before it
That-
got boiled.
Very good. That's the mass of the water. That's the mass of the water before it evaporated. Very good. So who can tell me how to set this up to get 40.5, which is the answer? 40.5%. Who can show me how to set this up? Go ahead.
You would put 3.69 over 9.10.
Yep.
Times it by 100.
Very good. There it is. 40.5% is the answer. This is a Regents question. I forget what Regents, it was a while ago, but that's a typical Regents question. The ones on the front, I've seen them, but they're less common because I think the Regents thinks they're too easy. So they give you a word problem, doing the same concept. Okay. All right, put that away. I'm going to give you a worksheet right now to work on, and we'll see where you're at. And then we will go over it. I know you learned about this, but it was it's a tough concept, a little bit. Oh. Okay, so once everybody gets this here, you're gonna do. There's a lot on the front. Let me just cut all the nonsense out. So look up here. You're just gonna fill in this chart, and that's it on the front. Skip all the stuff on the bottom. Flip it, and then do 3, 4, 5. 4 is the hardest, so maybe you want to do that last. Do 3, then 5. I guess it doesn't matter, but see what you can do. We will be going over this. This is classwork right now. Oh, if you need a calculator, come on up and get one. Do not use your phone. I don't want to see your phone out.
Are we gonna forward this before?
Probably not. We probably won't get through everything I want to get through.
Should we use a fancy one? Take this one.
Oh man, this is the most beat up piece of
Easy. I'm being recorded here.
Dumb.
Legal document. Doesn't make any sense. Before I actually let you continue,
yeah.
who can tell the class what the difference is between empirical and molecular?
Doesn't it just change the way they're written?
Good man. Anybody besides Ryan? Anybody besides Ryan? Difference between molecular and empirical. Go.
Isn't it
Simplified, right. So if I gave you an equation, if I gave you, let's say, C4H10, that's your molecular formula. Empirical would be, so if this is the molecular, the empirical, say it again? C2H5, right. Because you can reduce that by 2 and reduce this by 2 to get C2H5. So the empirical is the reduced version of the molecular. And I just want to make something else clear before I really let you go here. If I was to add the mass of 2 carbons, make sure you're paying attention, this helps do the back of the worksheet. 2 carbons and 5 hydrogens, that would be 12 plus 12, which is 24. 24 plus 5 is 29 grams per mole. So that would be the mass, because carbon's 12 and hydrogens are 1. So 12 and 12, 24 plus 5, 29. If I was to add this up, 4 times 12 is 48, right? 48 plus 10 is 58 grams per mole. What do you notice about these two numbers? How are they related?
Grams per mole.
Yep, good. Something else. How many times larger is 58 than 29? 2. No, Ryan, hold it. Hold it. This number is 2 times larger than that number. That's because the compound is 2 times larger than that compound. So when you're doing the questions on the back, like number 3 and number 5, you need to understand the ratio here. There's always a ratio between molecular and empirical. It's a whole number. The way you figure it out is get the formulas or get the mass. Either way, you can get one or the other depending on what you know. So I'm not really telling you exactly how to do it, but it should help. Okay? So do that box, the chart on the front, and then do the 3 on the back. Go ahead. I'll take it from you. Nope. Goodness, it's waited for me. There's still water in here.
It tastes like laundry.
Do your work. Yeah, you may need it. Again, 3 and 5 you should be able to do. 4 is harder. You can't do it, I understand. What I'm passing back now is not homework, it's a review sheet for that quiz Thursday. I will read the answers to it on Wednesday. This is not a graded assignment, so if you don't want to do it, you don't have to. Just study, nothing study. Don't do that. What? Don't do that. I'd rather you not use your phone.
This is homework.
No. Who asked me that?
I did.
No. It's a review sheet for your quiz Thursday. I will read the answers Wednesday, but it's not graded. So it's not, I'm not checking it for homework, it's just practice if you want to do it. I'm gonna give you one more minute. It's okay if you don't get it done. This is just to kind of see, you know, where you're at with this stuff, more for you. So if you don't know how to do this, really make sure you pay attention when I go over it. Okay, so if you had a clue, then you're probably done with whatever you can do, and if you didn't have a clue, you're just sitting there anyway. And that's okay. I don't mean to be mean when I say that. So let's go over the first page there, the chart. Kristen, can you look at Jake's number 1 and just check it for him? Okay, who wants to bang out that chart real quick? Give me a wall. Isla, sounds good. Yeah, go ahead. CH, good. That's because it can't reduce. Yeah, you thought right. Yeah, so just CO2. BH3. CH. Same thing, CH2O, can't reduce. Close. You can reduce it one more time. CH2O, right. Yeah, that one's tricky. So CH2O for glucose. Good job. All right, here we go. Number 3. Here's how we do number 3. Actually, did anyone get an answer they want to share? Shelby. C5H10. Let's find out. So CH2 has a mass of 14 grams per mole. 12 plus 1 plus 1. So 14 grams per mole. Use the other one here. We are trying to find the molecular formula. So I'm just going to put CXHY, meaning we don't know the subscripts. Okay, we know it's bigger than CH2. We don't know how much bigger. We do know the mass of the molecular formula is 56 grams per mole. So, what I was trying to show you earlier helps here. Shelby, how many times larger, how many more times larger is this number than that number? I'm not phrasing that well, but how much larger is 56 than 14? 4 times, right. 56 divided by 14 equals 4. So you were close, right? This formula is 4 times bigger than that one. C4H8 is the answer. Very good. This is a pretty typical Regents level question. They give you the empirical formula. They don't tell you the mass of the empirical formula. You have to figure it out. They do give you the molecular mass. You have to find this mass, see the ratio. It's 4 times bigger. Then you just multiply the subscript by 4. So C4H8. Okay, typical Regents question. I know you talked about molecular and empirical stuff when I wasn't here, so I'm not going to hammer this stuff. It's also not incredibly common, but if there is an empirical molecular question, it's probably or most likely something like this. So that's why I'm doing it with you. Let's skip 4 for a second because it's harder. 4 is a little bit above Regents level. The 5 is a Regents level question. I saw a bunch of you had the right answer here. So number 5, who wants to share? Go ahead. D?
Yeah.
Yes, it is D. Here's why. C5H10, if you add up all the masses, it adds up to 70. You have 5 carbons, each with a mass of 12, that's 60. 60 plus 10, 70. So that's D. Good. All right, number 4. Does anybody have any idea how to start this? PO2? Good try. Bree? That's too much work. We already have a lot of work to do. We can skip that. Good try. Thanks for trying. Who else? All right, I'm going to give you a hint. We're going to take 43.7% and 56.3% and imagine instead of percent, it's labeled grams. So we have 43.7 grams of P and 56.3 grams of O. So we have 43.7 grams of P and 56.3 grams of O. Now we need to turn those numbers into moles. How do we do that?
Alright, so there's 22.1.
Charlie, how do we find moles?
So for P there's 31
In
grams in a mole.
Very good. So I'm going to stop you there. Good. So P, he looked over there and got the gram formula mass. So there's 31 grams in 1 mole. So go ahead, Charlie.
31 grams per mole, so then you're going to divide that by 43.7.
Yeah, so I'm going to set it up here. I have 43.7 grams. How many moles is that equivalent to? Charlie's doing the same thing. I'm just showing you step by step. So this is your gram formula mass. Set up a proportion. If 31 grams are in 1 mole, how many moles are in 43.7 grams? And then you do the same thing for oxygen. You have 16 grams in 1 mole, because that's 16 over there, or in your periodic table. So how many moles are in 56.3 grams? We solve for moles here for both of these. And someone do 43.7 divided by 31. Charlie, I'm assuming you did that?
Wait, it's 43.7 divided by 31?
Yeah.
All the way around.
No, yeah, 43.7, because this is going to be 31 times x.
1.4.
1.4 moles of P. Okay, someone do this one for me. 56.3 divided by 16.
3.5.
2.5?
3.5.
3.5. 3.5 moles of O. Now, we have 2 more steps to go. We're really ultimately looking for P, X, O, Y, in other words, these subscripts. It's not 1.4 and 3.5 because we have moles. We don't have atoms, but we can kind of cheat. Here's what we do. We divide both numbers by the lowest number. What? We have 2 numbers. We have 1.4 and 3.5. Which one's lower? Which one's smaller? 1.4. So we divide both of them by 1.4. This equals 1 atom of P. This equals, it's almost 2.5,
It's
2.4, 2.5. 2.5 atoms of O. So now we take those numbers and plug them in for the subscripts P1, O2.5. What's wrong with that? You can't have half of an atom. That's impossible. You either have a whole atom or no atom.
So you round up.
Close. We don't round up. We have to keep the same ratio. So our ratio is 1 to 2.5.
So it's 2 to
5.
2 to 5. Very good. We multiply them by 2, and the answer is P2O5. That's the empirical formula. That is somewhere between Regents Chem, AP Chem. That's the difficult level. I don't know where that falls, but you will not have to do that on the regents. So why are you doing it? So everybody says, why do we do it? Here's why. You have to know how to do each step separately, just not all in one problem. Okay? So you have to know how to convert to moles. Finding the number of atoms, that part's kind of sketchy for regents, but understanding the ratio is 2 to 5. That's the important part. So there's important things you're doing in the problem that you need in Regents Chem. You just don't need all of it in one problem. So that's why I did it with you. Don't stress that question if you're confused. It's okay. If you can do 3 and 5, you're in a good place. If you can look at that chart and reduce them, you're in a good place. All right? So don't stress about 4. Keep that sheet. I'll put it away. And take out your notes for 5. All right. So that's good. We did that. We did that. All right. I want to write a question on the board. You guys write it down and see if you can solve it. So this is in our notes. Calculate the atomic mass of Cl given the following. So, atomic mass and percent abundance. Okay, here we go. So just copy down what I'm copying down here. Make sure you're copying all that down, because when we go over it and solve it, it's not going to make any sense unless you have all that written down. So this could be a pretty typical Regents question. Probably, it could be multiple choice, but could be short answer too. They would always give you this information here. They would have to give you the isotope, the mass, and the percent abundance. Okay, we all have this down pretty close here. Evan, you good? Pretty close. 3. You know, I forgot to ask this question in period 2. Sometimes it's an advantage having it later in the day because my brain's working better than first thing. What's an isotope? What are these things?
It's a different.
It's a different. They're naturally occurring. Yep, these are naturally occurring. Well, what's the difference between Cl35 and Cl37?
It's the weight.
Good. The mass is different. Very good. This mass is almost exactly 35, almost exactly 37. But why do they have different masses?
Oh, because one has one less electron on the outside.
Neutron.
Neutron.
Yeah. This has more neutrons because they're both atomic number 17. This has 20 neutrons. This has 18 neutrons. So the number of neutrons changes, but the protons stay the same. That's why it's chlorine. We're going to talk more about that with nuclear chem. But these are naturally occurring. The percent abundance is, okay, if you find chlorine somewhere in nature, 77 or 76% of the time it's going to be this Cl, and 24% of the time it's going to be this Cl. This one's much more abundant. Much more abundant, which is why, if you look over there, the atomic mass is 35.4527. Where that number comes from is a weighted average of all this information. So it's going to be closer to 35 than 37 because this is weighted more. It's kind of like your quiz average in here is worth 60% of your grade. Homework's worth like 15 or 20. So if you do all your homework, that's awesome, that's great. I want you to do that and you get all those points. But if you do all your homework and you get a 50 on every quiz, your overall average is going to be closer to a 50 because your quiz average is weighted much more. Usually when I say that, that makes more sense to students because you know it's something you care more about than this, to be honest with you. But it's the same concept. So how do we take a weighted average of this? I know we're almost out of time, but we got another minute. How do we do it?
Divide that by 100. So
Divide this by 100.
Yeah.
Sure.
And then multiply it times the atomic mass, and then add them together.
Perfect. Are you like a math savant? In other words, math just comes to you? Very good. She said, listen up. She said, divide these percents by 100, multiply it by the mass, then add the numbers together. That's 100%. That's confusing. How to do it. That's how you do it. Very good. We'll do it tomorrow. You can pack it up. Good job. I'm going to change it a little bit, though. I'm not going to divide those numbers by 100.